work, energy, and power. Right? So it is a physics chapter, a very easy chapter to learn, where you learn basically about 3 or 4 equations. Yeah, 4 equations, four formulas. Very easy to apply. Theory is very simple. But it comes in the questions in part 2 as well. Part 1, part 2, and 2. Again, in part 1, MCQ straight away you have to apply the point. Right. First, let me take the topic word. So, what is this word? Work, it is something we do a work spending energy. We do a work spending energy. So, what is the energy spent should be equal to the work done. Work done. So, how do you obtain the work here? Let me take simple. Give me a minute, please. So, let me take an object here. Look at this, guys. So, on this object, I'm going to apply a force. I'm applying a force, right? When I apply a force, this object is moving a certain distance and come to this point. The object comes to this point. So the same object has come here. Now this is the distance it has moved, right? Because of a force you apply, the object has moved a certain distance. I'll take the distance as right, and it should be a perpendicular distance. And the distance you have to measure in between 2 points. Okay, in between 2 points. So what are the 2 points? One, either from the center to the center. Look at the way you have to measure. Center to center. Or else the starting point to starting point, ending point to ending. Okay, this is how you have to get the measure, the distance. So what is the work? The work done you can obtain by multiplying these 2 factors. What are the 2 factors? The force into perpendicular distance. Perpendicular distance. Force into perpendicular distance, you can find out the work done. So the work done is equal to F into D. F into D. So work we are giving the symbol as capital W, but in our level we do use that symbol because some other places we are using the W. So let me write it as work, F into D. And this force must be measured in Newton. Distance must be measured in meter. Any other units you have to convert. Okay. So the work will be given in Newton meters. And this Newton meters is said to be equal to joules. Joules. So accordingly, Newton should be the unit of force, mass, distance should be in meters, work done should be in Newton meters. As a standard unit, we are giving joules. Okay. So accordingly, this is the formula we are using to find out the work done. Okay. And sometimes the questions will be giving you the kilograms. Right? If the kilograms are given, we have to convert these kilograms into Newton. Sometimes they give grams. The work is done against a gram, a number of grams they give. Then you have to convert the grams into kilograms and then kilograms into Newton. Accordingly, you can find out the force. Distance, if it is given in centimeters, you have to convert it into meters. Okay, the conversions are what I am giving you here. What is the conversion here? Let's say, if the mass is given in grams, then the grams you have to divide by 1000 to make it kilograms. Okay. Grams you have to divide by 1000 to make it kilograms. And then the kilograms you have to multiply by 10 to make it newtons. Grams to kilograms, kilograms to newtons. Okay. Same way. So these are the unit conversions you need when you are writing answer. Same way, if the centimeters are given, we can't apply centimeters, right? You have to convert the centimeters into meters. How do we convert? Divided by how much? 100. Because 100 centimeters are equal to 1 meter. You understand? So this is a simple theory. So using this theory, you have to write down the answer. So look at the first question. What is the first question there? What is the amount of work done when a mass of 20 kilograms is lifted to a height of 5 meters? So How do I find out the work done? You have write formula F equal to. Now is F given there? Can you tell me? Is it giving you there? No, right? What is it giving you? Kilograms given. Then how do you convert kilograms into Newton? Multiplying by 10. How many kilograms given? 20 kilograms. So I'm writing 20 into 10. Straight away I'm writing Newton. 20 kilograms multiplied by 10 Newton. Why 20 kilograms into 10? 1 kilogram is equal to 10 Newton. Because we take the gravity as 10. Gravity as 10. So since the gravity is 10, 1 kilogram in 10, it is 10 Newton. So 20 kilograms into 10, 20, 200 newtons. 200 newtons. So 20 into 10 0, what is the height now? Height is 5. It may be height, depth, length, whatever. All of them are distances, right? So it is 5 meters. How much is the answer? 20 into 10, 400 into 5, 1000. What is the unit? Newton meters means I can write it as joules. 1000 joules of work done. You understand that? Is it point clear? Okay. Right. Shall we write this down first? There's a text box given, right? Text box given. So you take like this. Okay. Here the text box is. One side you can draw. Just small diagram, right? You can draw here. And then the next side, the right side, you can completely write it. Okay. Please write it down. Right, right. Right. Right there. Right. Right. Now we can write the answers for the next. 1, 2, 3, 4, 5. Before 5 questions are there. Get the answers, and again I'm reminding you, if grams given, divide by 1000 and multiply by 10. At the same point you can write. For example, let's say 20 grams given, 20 dividing by 1000 into 10. 50 grams given, 50 dividing by 1000 into 10, you can write the difference. You have to take it as n. And then multiply by the distance given. Okay. But formula is must. Always write with the formula. Take the writing. Just write the answer with it. Revise it, revise it. Okay. Always try to write in one line. Write the formula for every question. Every question you write work equals technically. So this way write the units, okay? You have to write the units like Newton into meters. Newton into meters. Right? And get the answers in Newton meters. Take all the answers in Newton meters and you are writing the for now. Right? Newton meters. Look at the second question. Write the answer in Newton meters. Right? What is it? Look at the second question. Mass of a packet of sugar is 2250. Find the amount of work done when it is lifted to a height of 1.5 meters. Now, we assume in all these questions, we assume that what is the gram, what is the mass equal to that weight. Mass will be having a weight, right? Equal to that weight only, we are giving the force to lift it up, move it up. Okay. So accordingly, here the work done is equal to F into D. What is the force? 2250 should be divided by 1000. Why? To convert it to kilograms. It is given in grams, divided by 1000 to make it kilograms. But I need the force. Then the answer I have to multiply by 10. So don't go to the next step. Write weights and take. Now I'm writing it. Correct? 2250 grams. Divided by 1000, then it becomes kilogram. And then that answer I multiply by 10 to make it kilogram. So both the set up both the conversions at once I'm writing. Now I multiply by 1.5 meters. So this gives me when it is three numbers. Whatever. 3 times I will take the decimals front. Okay. Here the decimal is 2400 means of one complete number and whole number. Decimal will be there here. So once, twice, thrice. 3 times you take. Then it is 2.25. Then you multiply by 10. Multiplication shift less. So another decimal goes over. Then it becomes 22.5. So 22.5 Newton into 1.5 meters. This gives you 33.75 Newton meters. 33.75 Newton meter. Take all your answers in Newton meter. Dividing by 1000, right? So 3 zeros are there. 3 times you have to take it from. So then 2.2 multiplying by the 22. Actually, that's maths. Okay. Take it Newton meters. At the moment, take it Newton meters. Don't write joules because next part you might confuse because next part is what the energy is connected. Topic work, energy, power. So energy, I told you energy spent is equal to work done. So you can give it as joules as well. But at the moment, take it as Newton meters. What about the next one? Third question. The mass of a man is 50. What is the amount of work done when he climbs to a height of 6 meters? Again, work done is equal to force into distance. So you see the way I'm writing. First I write the formula and all the equal marks in one line and for a particular question. So don't write here and there. You have to learn that. Okay. If you write here and there, your answer is not clear. Moreover, some points you may miss, some steps you may miss. Okay. So always take it in one line. Suppose 50 kilograms, right? Kilograms means I multiply by 10 to make it Newton. I have write this unit as well. Don't just write only the numerical value. Write the unit. 50 into 10 newtons. And then what is the height? 6 meters. 6 meters. Just write it as Newton meters. There we go. Newton. Because some of you people are writing Newton meters, some are writing Joule. Because of that. Okay. So Newton meter is the fundamental unit. Joules is the standard unit. So all the answers you are writing here, you can give the final answer as joules. You understand? So you are learning this, right? So 3 answers, 3 examples you wrote like. So next one I am going to take it as in joules to show you that it is the SI unit. You understand that point? Point clear? Otherwise, in case if you are writing only joules and if it comes in Newton meters, you might get confused. So Newton meters is the joule. So every answer you can give it in joules. Do you understand the point? Okay, right. Look at the next question. What is the next question? Calculate the amount of work done when a mass of 50 kg is lifted to 20 meters. So work done is equal to F into D. 50 kilograms into 10 to make newtons into how many meters? 20 meters. Now I'm going to take the answer this way. 50 into 10 is 500 into 20 10,000. You see now 10,000 Newton meters I can write it as 10,000. Okay, now abridging I am doing and the next question straight away I am going to take it as joules. Do you understand that? Okay, right. What about the next now? Next question. What does it ask you? The work done when a box of mass 20 kilograms is lifted to a height of 550 for a certain height, it is 550 Newton meters. Okay, so 550 Newton meters of work done. 550 Newton meters of work done there. The question asks you to find out that height. How do you do? Now the work done is equal to F into D. Who we want to find? D is what you want to find, right? Because height means it's a distance, right? So I'm writing D is equal to the work done over F. What is the work done now? 550 Newton meters. Upon reading, you have to figure out that is 550. Or else you can see Newton meters given, right? That means it should be the work done. Should be the work done. So you see this 550 Newton meters I'm going to divide by how much is the force given? How much is the force? 20 kilograms, right? So I'm writing 20 into how much? 10 Newton. Kilograms into Newtons, you have to multiply by 10. Okay. So how much is the answer there? I don't have space, I'm writing here. 20 into 10 means 20 into 10 means 200. Okay. 550 divided by 200, how much is it? How much is it? Check. 2.75 meters. Check it if it's correct. 550 divided by 55 divided by 2 means 27.5. One more zero is there, 2.75. 2.75 meters. Okay, these two zeros you can separate. Then 55 over 2 means 27.5. 27.5 dividing by 10, 2.75. Meters, because distance, right? You are writing the answer of distance. So it cannot be Newton meters, it should be meters. Meters. An object was pulled for 5 meters at a uniform force. The work done was 750 Newton meters. Find the mass of the object. I'm writing here. Let me take this point. F into D. Works given. Find the mass. Find the mass. So what I do? I first find out the force. Look at this. What am I doing? I know the work. I know the distance. So first I'm going to find out the force. Draman. First I'm going to find out the force. How much is the work now? How much is the work? Tell me. 750 Newton meters, right? Dividing by how much is the distance? What is the height? 5 meters. 750 divided by 5. How much? How much? 150, right? Again, 750 divided by 5, 150. So 150 force means newtons, right? Again, force means newtons. Now the force I want to convert into mass. Yeah, can you remember earlier? Kilograms multiplied by 10 to make it newtons, right? And then opposite, divide by 10. Okay, but you can't just write here. Hence, right? Mass is equal to 150 divided by 10. That means 15 kilograms. You understand? How is this equation coming out? Weight is equal to mass into gravity. So the mass is equal to weight over gravity. So this is the formula we are using here. Okay, weight is equal to mass into gravity. That is the relationship between weight and the mass. Weight is equal to mass into gravity. If the mass should be equal to weight over gravity, weight is 150. Force means that the weight, right? Gravitational force is weight. 150 Newton divided by the gravity, 10 kilograms. Okay, so this is our answer. 15 kg. Okay, right? So it is the first part. Let me take the next one. Energy. Now work done is equal to energy spent. Work done is equal to energy spent. Okay, and this energy, energy, it is the ability of doing good. Energy is the ability of doing good, right? And we do have different forms of energies. Have a look. We have different forms of energy. Can you give me some examples? What are the types of energies you have? Roman. What are the types of energy? Kinetic energy. Right. Types of energy. First one I'll take mechanical energy. Mechanical energy. This mechanical means physically we are engaging in some energy. Mechanical, right? So this mechanical energy is of two types. What are the two types? Kinetic energy and potential energy. Kinetic energy and potential energy. Some may say kinetic energy also, but basically we are using kinetic, right? Kinetic energy, K, or else also is EK. Kinetic energy is the energy stored in moving objects. any object in motion. Now I'm rest. It may be living or non-living. If we are rest, if the object is rest, no energy stored. I mean, no kinetic energy stored. Some other energies may be there. Kinetic energy is zero if we are rest. If I am moving, when I am moving, a moving object contains stores and energy. This is called kinetic energy. Kinetic energy. And next one is potential energy. Potential energy refers to the energy stored in an object because of two changes. One of the change. What is that? Either the shape is changing. Either the shape is changing. Example, let's say now this is having a shape, right? Okay. Now I'm pressing it. You can see the shape is changing. Okay. Now when I take my hand, will it be staying the same? No, right? It comes back. Why is that? Because when I change the shape, it stores energy. Okay. When I leave pending that energy, it comes back to the earth. A rubber band you take. A rubber band you take. When you stretch a rubber band, it stores energy. This energy, due to the shape of the change of the shape, we name it as elastic potential energy. What potential energy? Elastic potential energy. A rubber band, an elastic band, something you are stretching, and you leave. Will it be staying there unless you are connecting? If you are connecting either side, that would be. If you take it off, it comes back, right? It comes back to the same original position, original shape. Correct? So this is elastic potential energy. Elastic potential energy. So the other one is because of the change in the height, the position from the ground. Okay. Now, when you people were at the ground floor, your potential energy is zero. Let's say we consider ground is zero. At the potential at the ground, you don't have a height. From the ground, you don't have a height. So your potential energy is zero. Okay. But something you leave down. You are holding this marker. Imagine this is the ground. You are holding this marker. Now this marker, your body is one system, right? So this marker, okay, you are just holding on. There is a height. To my hand's height, there is a height, right? So to this point. So there is an energy stored here. When I take my hand off from the marker stays there, it falls down. Why? Spending that energy. The stored energy would be spent to move it down. And this energy stored because of the height is called gravitational potential energy because it's against the gravity. Against the gravity. Now you are in the first group. Energy stores. What is energy? Gravitational potential energy. Because of the change in the height. Okay. So all of us will be having gravitational potential energy. Okay. All of us we are having gravitational potential energy stored. But different amounts of gravitational potential energies are there. Under that topic, we will speak about what it is. Okay. So anyhow, being the first flow, we have some gravitational potential energy. Okay, depending on our body mass and all, that is different. So two types of potential energies are there. What are the two types? One is called gravitational potential energy. We term it as GPE or as EP, and the other one is called elastic potential energy. Elastic potential energy. So this is about the mechanical energy. Mechanical energy. Give me some other examples of energy. What are the? We have light. Okay, light energy. Heat or thermal energy. Water is not an energy. Okay, water is not an energy. When water is stored at reservoirs, what is the matter? When water is stored in dams, reservoirs at a certain height, it stores gravitational potential energy. When the water flows down the stream, kinetic energy. Kinetic energy. Understand? So energy is different from matter. Energy is different from matter. So heat energy. We get from sun. Solar energy we see, but solar energy contains two primary energies. What are the two primary energies? It gives you light and heat. Light. Light lamps. You can touch the lamps, but can you touch the light? Light's coming down. We get light. We feel light's there. We can see each other because of light. But can you touch the light and say this is light? Light lamp you can touch. Can you measure 5 kilograms of light coming down? Can you measure? Sun gives tons of kilograms of light. Can you tell that? It's not matter. It doesn't have space, no mass. Energy, no space, no mass. Got it? But it appears. Then what happens? Energy you can't produce. You can't create energy. You can't create energy. You can't destroy energy. I'm taking a sound energy, I'm collecting, I'm going to destroy. Can I do that? You can't. You can't. None of the energies you can destroy. Only thing is, from one to another type, from one form to another form, you can convert. You can convert. So energy could only be converted from one form to another. Like turning on the switches here, electric energy given to the light lamp, it gives you light. Electric energy is converted into light energy. Fans rotating, it gives you wind. Wind is moving, kinetic energy. So electric energy is converted into kinetic energy. Electric iron, electric oven, electric kettles. Electric energy is converted into heat energy. Understand? Yes. Sun? Yeah, sunlight means solar energy. This solar energy gives you two light, two energy. What are the two energy? Sunlight, sun heat. Light energy, heat energy. Solar heat, solar light. Okay. So solar is also sun. Okay. So these are the energy. And what else? Chemical energy. We store chemical energy in our body. In our body. That does it mean that we are drinking chemicals? No. We are eating, right? We are consuming food, right? Food contains chemical. Chemical energy is of soda. That is why in the first lesson you learn chemical basis of life. Carbohydrates, proteins, and all. But it is chemical basis. Otherwise, it doesn't mean so. Whenever the word chemical comes, you think like some sort of laboratories are there storing chemical. Our body is chemical. It contains a chemical parts. Chemistry is a part of science. Is that clear? Okay. So see, chemical energy, and then electric energy, magnetic energy, right? Nuclear energy, sound energy. Sound is also energy. Sound is also energy. Some forms of energy is out here. All other different words they are using, they contain the same. Okay? They contain the same. For example, geothermal energy. Geothermal energy is obtained from the Earth's crust. Geothermal. What is that thermal? Heat. So primarily, what is that energy? Heat energy. Heat energy. Wind energy. Primarily, what is the energy? Kinetic energy. Kinetic energy. Flowing water's energy. Kinetic energy. Okay, is that clear? So these are the primary energy forms. The only thing we could do is one form to another form we can transform. You understand that? Okay, so let's write there. There are some lines given, right? First one, straight you can write. Rest of the parts you are writing, maybe 2 or 3 lines, one be sufficient. You can write in front of that, you can put a tick and you can write. On the dude itself. Sit properly, sit properly. Come on. And in this lesson, basically, we are going to speak about this kinetic energy and potential, gravitational potential energy. Then Right? We'll explain kinetic energy. Kinetic energy. In front of kinetic energy, we write small line. Opposite to that topic. But inside the text box. But inside the text box, opposite to that topic, kinetic energy. Always in front of the word space there. The energy stored in the energy stored in the energy stored in a moving object. The energy stored in a moving object is called kinetic energy. Called kinetic energy. Energy stored in moving object is called kinetic energy. Right. Let's say this is the object. The object is having a mass m, guys, and it is moving at a velocity v. Velocity v. Mass is m, velocity is v. Speed is v. So any object in motion stores an energy called kinetic energy. So how do we find out the kinetic energy here? Kinetic energy is equal to. Learn the formula. Now earlier formula, what was the formula here? Work is equal to F into D. Work is equal to F into D. That is the first formula. Second formula, half into mass into velocity square. Velocity square means velocity you have to multiply 2 times. That means not by 2. It's not multiplied by 2. Velocity into velocity. If the velocity is 5, 5 into 5. Velocity is 10 into 10. The power you have to do. Square you have to make. Understand? Velocity is 100, 100 into 100. Velocity square you have to make. Right? So, kinetic energy is equal to half into m into v square. Half into m into v square is the formula here. So, here the mass must be measured in kilograms. Velocity must be measured in meters per second square. Meters per second square. Okay. That means meters per second only, and then you have to multiply meters per second, you have to multiply like 2 times. And the kinetic energy at last will be given you in joules. And remember what earlier I told you? Work done is equal to energy spent. What is the work done? Is the energy. So both of them can be measured if you want. You are measuring in joules straight away. So what is the formula here? Kinetic energy is equal to half into mass into velocity square, or else half mv square. Half mv square. Does the text box given? Inside to the left side, draw this and then write this down. Right. Okay. You can stand it. That you can stand. Yes, yes, let me down. I done. Don't try to ask the person to give the word again. Right. Take the very last page on YouTube. 2 pages are given for notes. Take the page number 7. Page number 7. Take the page number 7. Right. There we write, guys. The last page, page number 7. 7, 8, 2 pages are there. Take the page number 7. We are going to write some short notes there. Take the topic work. Work. There we learn works equal to F into D. This is the formula, right? Work is equal to F into D. We're going to speak about some relationships here, some changes, some interactions. So look here. Look here. Work equal to F into D, right? Work equal to F into D. Let's say if you're going to make the work constant, if you're going to make the work constant, if this person is constant, these two should be inversely proportional. These two should be inversely proportional. So F is inversely proportional to inverse proportion means let's say you increase the distance, F shall be decreased. You decrease the distance, F should be increased. F should be increased. Is that clear? Okay. So force is inversely proportional to distance. Okay. Force is inversely proportional to distance. If you increase the distance, force is decreased. If you decrease the distance, force is increased. And the second one, right? This is the first one. Now I'm taking what if force is constant? Who is constant? Force. This person is constant. If this person is constant, these two you can see. How do you find out the proportionality? Either side of the equal mark, you can see both sides. Guys, these things don't learn even. They are not supposed to teach this. This part I'm not supposed to teach you. You have to, because 100 equation you learn, all 100 times you can't teach, but I do. Right? You have to get the points properly. Right? So every time I'm speaking about that, I'm reminding you the method also. What is the method? Equal mark, both sides you take. Now, if this is constant, this is constant. Then whom you have to compare? You have to compare D and 2. Both sides of the equal mark and both of them are numerators here, right? Both of them are above the line. Numerators. Correct? Numerators means A means A over 1, right? B means B over 1, right? So likewise, work over 1, D over 1. So both of them are numerators means you have to take it as directly proportional. Both of them are numerators directly proportional. Okay. If both of them, one is numerator, the other one is denominator, upright term, one is up, the other one is below the line, then you have to take it inverse. So here what happens is, work is constant, then these two are in the same side then. Same side then. Let's say if you take it, then how come it is happening? Work over F is equal to B. Correct? When you take this F here, because work is the constant, now you can see, one is above the line, the other one is below the line. One is above the line, the other one is below the line. So I put it as inverse proportion, 1:1. But here, work is equal to F into D. I'm taking F is constant. These two are either side and above the line, right? So I have to take it as it works directly proportional to D. That means keeping the same constant, you increase the distance, work increases. You decrease the distance, work has to be decreased. Understand? Is that clear? Okay. So for example, let's say this object. Okay, this object. Now this object I do have here. You see, I'm giving a force. I'm giving a force. It's moving. A certain distance is moving. So I can find out the work. What is the force I'm giving into distance? Now let's say, okay, I'm having the same force. Same force. Look at this. I'm moving a small distance here. Right? I'm doing a small work. Again, I'm doing. Okay, you see here, distance I'm going to increase. I'm giving the same force. I'm giving the same force, but the distance is increasing. Then the work done will be increased. Giving the same force. When the distance is increased, work done will be increased. When the distance is decreased, work done will be decreased. Understand? Right. Same way, the third one. Now I'm going to take work equal to F into D. I'm going to take D constant. That means if distance is constant, what is constant? Distance is constant. These two, tell me, is it proportional, direct or inverse? These two, are they direct proportion or inverse proportion? Tell me. How is it? This is the constant value, right? These two are either side of this polynomial, above the line, right? Then is it direct proportion or inverse proportion? Direct proportion. Direct proportion. So I can take it as work is directly proportional to force. So you increase the force, work increases. And you decrease the force, work decreases. That means, now imagine same distance, the length of the table, length of this table. I'm giving a small force, a small work is done for the same distance. Now I'm giving a big force, but the same distance. Work done is more. Work done is more. When you increase the force, work done will be more. Did you understand that? Okay. So this is the relationship between the three factors and the work. Could you please write them down? Done. Shall I erase? Arre. Now I'm going to write the same like relationship on this kinetic energy. Kinetic energy. Look at this. Take the topic. Kinetic energy on the two. I mean, they are the same case. We are writing the short one. What is the formula? K is equal to half into m into v square. Okay. This is a formula, right? This is a formula. Okay. So I'm going to take now. Look at this. First I take if look at this. Kinetic energy is constant. This constant. Ke is constant. This is constant. Look at this. If this is constant, these two are the same side, right? Then one person I have taken the other side and compare. Let's say M I'm taking here, or B square I'm taking here, then it comes as division, right? This M I'm taking here becomes KE division M. For V square, KE division V square. That means one is up, the other one is down. Then one is up, the other one down means tell me is it direct proportion or inverse proportion? Inverse proportion. So if KE is constant, I have to say mass is inversely proportional to V square. But the thing is V square, double of them. Okay. Parallelly, at the same rate it can't be changing. Double. Double in the sense actually power. Okay. So then I can take it as what it means. You increase the mass, velocity decrease. So the product will be velocity square. Okay. You decrease the mass, velocity increases. Okay, you can take it as velocity square. Velocity square. Okay. You increase the mass, velocity square by a double it decreases. You decrease the mass by a double, the velocity square increases. Okay, as a power it will increase. So let's take the next one. This is one, and the second one. Look at this. Now I'm taking if M is constant. So look at this. Who is constant? Mass is constant. M mass is constant. If mass is constant, these two things directly proportional, right? Can you see that? This is constant means either side above the equal mark, above the line. So I can take it as K is directly proportional to V square. That means you increase V square, K increase. You decrease V square, K decreases. K decreases. What do you mean by that? Look at this. Look at this. I'll take an example. Have a look. The mass is N. An object A, mass is A. First listen, don't just copy paste. You have to understand. So that I'm giving examples also. Mass is A. Sorry, mass is N. Mass is N. The object A. Object A is having a velocity V A. Okay. And object B, same mass. Mass is same. I'm writing M M. I'm writing M. Okay. It's having a velocity VB. VB. So what I say here, let's say mass is same. Mass is same. But velocity B, I'm saying more. Velocity of B is more than the velocity of A, I'm saying. Whose velocity is more here? I'm giving you as a data, B's velocity is more. So, as per this formula, the relationship, whose velocity is more here? This one. Then whose kinetic energy should be more? This person kinetic energy should be more. So, when the masses are same, again, since VA, VB you take. VB is more. VB is more, right? So VB is more than VA. It's VA. Some we have 5, let's say. This is more than 5. More than 5. So since VA is less than VB, VB is more than VA. I can say kinetic energy of A and kinetic energy of B you compare. Kinetic energy of B is more. Kinetic energy of B is more. Did you understand that? So simply mass is same. Who has the more velocity will be having the more kinetic energy. Like same like. Now I'm going to compare whom I'm having now B. If B is a constant, B is constant, velocity is constant. Then what happens? Kinetic energy will be directly proportional to mass. Here also the same rate, either side of the equal mark above the length. Above the length. What do you mean by that? You increase the mass, kinetic energy increases. You decrease the mass, kinetic energy decreases. Kinetic energy decreases. So what do you mean? Look at this. Mass of A, mass of B. Okay, mass of B. Velocity is same. You see, I'm marking B, same velocity. But let's say if mass of A is more than mass of B, mass of A is more than mass of B. Okay, then whose mass is more should be having a high kinetic energy. So the kinetic energy of A is more than the kinetic energy of. You understand that point? Mass more means kinetic energy is more. For example, let's say always a usual example for a tomato and a pumpkin. Tomato and a pumpkin. Thin boy and a fat boy. Rolling towards you. Rolling towards you. Okay, imagine that Zishan and Azam. Okay. I was not supposed to take the example when I'm shaking about that. Those two people are looking here like this. So don't know, sir, will be taking us as the example. They are thinking, no? Azam, right? So we are looking like. So you are the examples here. So Zishan and Azam, Atin and Afai, rolling towards Shazin, let's say. Shazin. Who is easy to stop? Zishan. Why? Okay. Mass is less. Azam is somewhere double of them. Right? So mass is more. So it's hard to stop. Why? Here, energy he has will be more. If both of them are moving at the same. Let's say somewhat Zishan is flying while the other one is just scrolling. Then there would be a problem. We have to calculate and get it done. Both of them are having the same velocity, let's say. But one is less mass, the other one is more mass. Okay. Then who has the more mass will be having the more energy. Will be having the more energy. Okay. Clear? Clear about that? So thank you for you. Right? Okay. Did you understand the theory now? Okay. Let's write this down as well below that word part. Okay, not angry with me, not take you as example. No, then again I'll be taking. Write it down. Hurry up. Done? Done. Hurry up, please. Right. So let's come back to the views. Page number 3. Page number 2. Yeah. One more question we have there. Huh? I'm going to raise this. Hurry up, please. Hurry up. Right. Let's look at the question there. Look at that question. What is the kinetic energy contained in an object of the mass 3.5 kg moving at a velocity of 3? How do you find out? Kinetic energy is equal to half mv square, right? This multiplication without that I can write half mv square. Help me out. Half. What is the mass? What is the mass? Take the question. Tell me what is the mass? 3.5 kg. Remember, it should be kg. Given in grams means or divide by 1000. Okay. What is the velocity? What is the velocity? 3 ms minus 1 into 3 ms minus 1. Correct? Right. B squared over it. B squared means B into B. So 3 into 3. 3 into. So how much is it? 3 into 3, 9. 9 into 3.5. 1000. Is it 672? Okay. The decimal should be also added. 15.75, right? Check it. Check if it's correct. Fifteen point seven five. 31.5 becomes 15.75. And what should be the unit? Joules. 15.75 joules. Abdurrahman continuously speaking by that. I need to work. Look at the second one. An object moves at a velocity of 5 ms minus 1. What is the kinetic energy? Give me the answers for all three. You can write now. You can write. Hurry up. Three more questions are there. Again, I'm telling you, formula is must. Formula is a must. Okay. And then substitute them properly with the unit. With the unit. With the unit. Okay. How to write the unit again. Okay. Final answer should be joules. Hurry up. That's the answers. An object moves at a velocity of 5 kilograms 10. Kinetic energy equals half into mv square 10 kilograms. What is the velocity? 5. You have to definitely write the same way. 5 into 5, 25. Into 10, 250. Half of 250. 125 joules. 125 joules. Unit should be correct. Number 3. The kinetic energy containing in a moving object of mass 7,500 grams is to what? Find the velocity. Look at this. Whom you want to find here? Velocity you want to find. So this person you have to subject. How to subject? Brahman. The third time I'm telling your name, fourth time you out. Understand? What is on your hand? Keep it. Half into this square, right? Okay. So you want to find out B. So 2 and n you have to send here. How to take 2 when you take k becomes 2 into k, correct? Division 2, right? When you take k becomes multiplication. And this is multiplication in right. I'm taking here as division. So this is equal to b square. Okay, I'm having the answer b square. B square. So now b square is equal to 2 into, I'm writing this here. How much is the kinetic energy given? 240 joules. 240 joules. Divided by, how much is the mass? 7,500 grams. So I'm writing straightly 7.5 kilograms. Okay. Now you see, how much you get here? Somewhere 64. Okay, 64, right? 64. You are getting 64. But that is equal to B star then is that my answer? No, no. I'm sending it here. Right? So how much is B? 8. 8 meters per second. 8 meters per second. If the kinetic energy container object that moves at 15 is 900, calculate the mass. Now you want to find out the mass. Kinetic energy equal half into m square. Same way 2 into ke twice. 2 you take here, this square you take down. So it is equal to m. M equals. M equals. How much is the kinetic energy? 915. So 2 into 900 joules divided by v square. 15 meters per second into 15 meters per second. Correct? By 15 is the velocity, right? So velocity square. 15 into 15, 225. 15 into 15, 225. 900 over 225 is 4. 4 into 8. So mass is equal to 8 kilograms. 8 kilograms. Okay. I mean break. Don't you want to break? Can I cut it? Start break. 5 minutes. Last finishes after 2. No. We can have a break. Just for 5 minutes. Yeah. Okay. Whatever. Welcome, eruption. Hungry every day. Hungry. Right. We'll take next part. By potential energy. Look at this. Potential energy. Right. Look at this. Current potential energy is basically gravitational potential energy is what we are going to speak about. So look at that. Look at that. Potential energy of an object is the energy stored in the object due to height of position or the change of natural shape. Underline that. And if it is gravitational potential energy, it is because of the change in the height. Right. The gravitational against the gravity, the gravitational change in height. Example. Let's say this is the ground. At a certain height h, I'm showing an object of mass n. Gravity is down g. Look at this. So, how do we find out the gravitational potential energy? Gravitational potential energy is equal to mass into gravity into height. Mass into gravity into height. Very easy. So G10 is equal to m into g into h. M into g into h. Mass is given in kilograms. Gravity is given in ms minus 2. Height will be given in meters. Okay. So GP will be given in joules. GP will be given in joules. Not joules, joules, joules. Okay. So very easy calculations again. GP is equal to mgh. mgh. Mass, gravity into height. Mass, gravity into height. Okay. Look at the first question there. Find the gravitational potential energy of an object of mass 5.5 kilogram at a vertical height of 6. So how do you find out GP now? GP is equal to m into g into h. How much is the mass given? 5.5 kilogram. 5.5 kilograms. Into gravity is 10. What is the height? 6 meters. How much is the answer? 5 into 5. 5.5 into 10, 55. 55 into 6, 330 joules. 330 joules. Very easy. Mass into gravity into height. That is the first question. Okay. So fill it up on the tube. You know how to mark it. Draw this. And to the next slide, you can write. Write the first one's answer and give me the answer to the second question as well. Second and the third. Two more questions are there. Quickly do it. Take it down now. A fruit on a tree has a mass of 300 grams. Vertical height of the fruit from the ground level is 7.5 meters. Find the gravitational arc. Here, guys. G M into G into H. Okay. What is the mass now? 300 grams, right? Divided by 1000 to make it kilograms. Correct? I can't apply grams. divided by the work. Gravity is 10. What is the height? Height is 7.5 meters. How much is it? 0.3. 3 into 10, 30. 30 into 7.5, yes. 22.5. And what was it? 0.3. 3, sorry, 3. 3 into 7.5, 22.5. What about the next one? The gravitational potential energy of an object of mass. 0.75 kilogram at a certain height is 165 joules. Find the height where the object is placed. You want to find out the height. So height is equal to Gp over m into g, correct? Can I say this? Is mg half take here. H is equal. Height is equal. So how much is Gp? 165 joules. 165 joules divided by kilogram 0.75, right? Into 10. How much is it? 22 meters. 22 meters. Check if it's correct. 22 meters. Right? So three equations you learned. What are the three equations now? Work done is equal to force into distance. Kinetic energy is equal to Dishan. Kinetic energy is equal to half into mv square. You have to memorize them. Remember them, okay? Half into mv square. Potential energy, gravitational potential energy is equal to mass into gravity into height, mgh. Very easy equation. Always you have to give it in standard symbols. Look at the examples given there down. Water stored in a high reservoir, pilot tower, spinjam. Now water storage means even a tank you take, tank you can't keep it in the ground level and fill it up, right? You can't, you can fill it up, you can't transfer it. Otherwise you need a motor to connect it, it's useless. Okay, so usually we'll be having the tank at a certain height, right? The water tanks, the reservoirs, the dams, you will have at a certain height towards the hill contours, right? Why? Certain height when it is stored, a large amount of water stored, storing at that height, more potential energy, gravitational potential energy. When the gates are open, then that the energy will be converted into flowing energy. What is the flowing energy? Kinetic energy. So potential energy is transferred into kinetic energy by the way when it is flowing down. And when it is hitting on the turbines, that kinetic energy is converted to kinetic energy of the turbines and given to the dynamo, electric generator to produce electricity. So basically, kinetic energy conversion, potential energy to kinetic energy to electric energy conversion is what we are using in our hydropower plants to generate electricity. Okay, generate electricity. Right? Second example, pylon tower. Now, when you are making a construction site, when you are selecting a land, this land soil may be loose, may be loosened. So over there you can't once build up the buildings. So it's in a loose condition, loosely connected. Okay. So loosely connected, they do have some simple term I'm saying. Okay. They do have some gaps between ventilating spaces are there. So these loosely connected particles, you have to fix them. You have to compress them. How do you compress? Taking a hammer, going around the land. Can you do it? No. So what we do here, you would have seen cranes are there. The cranes will be lifting up large containers like structure, and then they will be moving it down. So huge amount of mass moving for a certain height stores potential energy. Now when it is lifted down, when it is moving down, like when it hits on the surface, it compresses the soil. It arranges the soil. So likewise, the entire land they arrange. So here also potential energy conversion into kinetic energy is what's stored, is what used. And the sledgehammer, large logs are there. Okay, logs taken from the plant. So huge rocks are there. Okay. Now you have to cut them into pieces. What do we do? We keep our wedge here, like a tool, nail like large tool. Okay, a larger tool we keep. And then what we do? The sledgehammer, we're gonna lift it. So lifting it up, it stores potential energy because of the height. And then we hit here. Now when it's hitting, it's converting into kinetic energy. The kinetic energy transfers and it moves to making the cracks. Making the cracks. So the logs are easy to be split over. Then after splitting one, it is easy to cut. So here also they are using potential energy as application. So in different ways in our day-to-day activities, we are using potential energy converted to kinetic energy. Kinetic energy. You understand that point? Okay, right. So like I say, we wrote short notes earlier, but this also we're gonna take a note. Take last page number 7 or 8. Page number 7 or 8. Guys, take the point. GPE, gravitational potential energy. Gravitational potential energy. Look at this now. Look at this. Gravitational potential energy is equal to m into g into h. M into g into h. mgh. So I'm going to take some points. If okay. M is constant. Who is constant? M is constant. Now this person is constant. Who are the other factors we have to compare now? GPE, GH. G is anyhow constant. G is gravity, right? So these two are constant here. If M is constant, H and GPE, you can see either side of the equal mark above the line. So I can take it as GPE is directly proportional to height. That means you increase the height, GPE is high. You decrease the height, GPE is less. GPE is less. Okay. So to identify these, we are doing a small activity, right? What is the activity here? I'm going to take some pebbles. I'm going to take some pebbles. And I do have a clay surface. I do have a clay surface. I have a clay surface. Now I have pebbles having the same mass. Same mass. Mass is constant. I'm having a pebble here. MA. And then MB. And then MC. Right? Same mass. I say the mass is same. If I'm writing here, if mass A is equal to mass B is equal to mass C, all same. But can you see the height? Height A. Okay. And this is the height B. This is the height C. Height A is more, and then height B, and then height C. What I can observe here, I can see at different heights when you are leaving it down. Is a clay surface, right? On a clay surface, when you are giving a force, the clay goes in, right? So I could see here the ball goes more in. It is depressed more. Depression this one. Depressed more. And here the depression would be slightly less. Here the depression would be even less than that. Even less than that. When you are drawing, you have to show that depression. Okay? You have to show that depression. Depression less, depressed more, and here even depressed more. It goes here. What is the reason? Height is more, energy stored is more. So the depression going down, you can see this is the depression. Again, the Bond's depression into the K surface. So more the force is given, more it goes in. So this is happened because of potential energy of A is more than potential energy of B is more than potential energy of C. Understand? Clear about that? So the depression is decreasing because the potential energy is decreasing. So it's clear GPE potential energy is directly proportional to height. Now you people are there here. Okay, you people are there here. You in, let's say I'm taking myself. I'm here in the first floor. First floor I do have a height, right? Okay. Imagine I'm going to the top of the roof. Now this height will be also added, right? So when the height is increased, what will be happening with the potential energy stored in my body? Will increase. Will increase. Okay. Example. Let's say, okay, I'm taking Shazin. Okay. I'm going to push him over on the balcony. He flies down, right? Flies down. It's on the ground floor. Again, I'm taking, okay, making him okay. Again, taking to the second floor, pushing him out, right? Which gives more pain? First floor, second floor, second floor. But assuming that he is a new person there, otherwise already the damages are there in the first floor. From the first floor pushing up. So now, why is the pain more? Because height is more. Height is more, energy stored is more. That entire energy has to be converted. So kinetic energy he gets down would be very high, very high. You understand that point? Is that point clear? So this is because of the height is changing. Height is changing. Now look at this point. Look at this. The second point. Now I'm going to take the height is same. If h is constant, who is constant here? H is constant. Height is constant. If h is constant, these two are directly proportional. Gp is directly proportional to the mass. You increase the mass, Gp increases. You decrease the mass, Gp decreases. Gp decreases. Example. You're gonna take mass of A, mass of B, mass of C. All different. They are not equal. Let me take it as, look at this. This is the variation of the mass. It is a variation of the mass. And this is the height, they are there. Height is same. Height is same. And you see all of them are having the same height. Guys, all three are the same height, right? You are going to leave them one by one. So here it is having the lowest mass weight. So the depression would be somewhere less. Here the mass is more, right? Depression would be more. Here the mass is even more, right? Depression would be even more. So it is the depression on the clay surface. So this is the clay surface I have. So you see what happens here? What happens here? When the mass is increased, potential energy is increased. When the mass is increased, potential energy is increased. So here you can see HA is equal to HT equal to HC. Height is same, right? Can you see height is all same, right? All the height are equal to H. But the mass A is less and mass B and then mass C is more. So GPE of A to GPE of B varies like this. And potential energy is more in C because the mass is more there. Mass is more there. You understand? Is that point clear? Okay. So accordingly, these are the relationship between the gravitational potential energy and height and mass. Height and gravitational height and mass. Note it down, please. Hurry up. Mass height? Yeah. Inverse proportion. Let's say when you are taking GP is constant, third point, I just speak about that. If GP is constant, keeping the same gravity, same gravitational potential energy, these two you take direct proportion, inverse proportion, inverse proportion. You increase the mass, height should be decreased. You decrease the mass, height should be increased to give the same gravitational potential energy. That is the third. That is the third. Okay. Take note. And elastic potential energy, more we don't speak about. You have to just remember a spring or a wire, an elastic wire, elastic band, rubber band, and you stretch, it stores energy. When you leave it, it comes back. That theory is a different theory, goes up to slow. It is a different load. You are not supposed to learn it. Hurry up, please. Hurry up. I have to. Right? So the next part is about the energy transformation power. We'll be taking it in the next class. Okay. Fine. Well done. Is it a hard lesson? Easy. But the point you have to accommodate so that it will be easy and easy practice. Especially in the talk. Okay. Right. Hope to have an online exam this week Sunday. Yeah, the e-test. We didn't have it. Right? E-test. Yeah, no, actually, I'm planning to make a seminar before that. Maybe at the end of this month. Okay. Because the revision class is a time. Revision class we were discussing in the last class to make it physical, right? So this week also we are having early morning. This time we had only 2 more weeks we do have. Okay. Only 2 more weeks we do have. Right. So what some other students they won't be able to do it physically at that time. Still I'll think about that how to do first. We sit up with on one seminar. Okay, as usual seminars, right? We'll be having a seminar. At the end of this month, inshallah, maybe a Saturday or a Sunday. Okay. If it is Saturday, last week of this Saturday. But during the morning or evening, we'll be having. In the morning or evening, we'll be having. Any other having class on Saturday? Any other class? Then the thing is, probably I might be having the seminar on Saturday. We'll see. Either Saturday or Sunday. Either Saturday or Sunday. So we'll see. I'll try to make sure Sunday with the hall. Then more hours. I didn't know hours. If it cannot be done, 2 days we'll have Saturday and Sunday both. Okay. Not enough. I need minimum 6 hours. We'll see. Yeah, otherwise it won't be a revision. So yeah, guys, something like making us saying so revision within 2 hours, I can finish up. Nothing you will understand. So nothing would be done within that 2 hours. What to do? Nothing to be done. 6 hours, 5 or 6 hours I need. We'll see. I'll try to make it on a Sunday, inshallah. Okay. We'll see what happens.